Hello everyone. Welcome back to you all. The session. I welcome you all for session 4 on NLP for beginners. Today we have a resource person with us, Dr. Shambhavi B.R. Dr. Shambhavi B.R. is currently working as associate professor in Department of Information Science and Engineering, B.M.S College of Engineering. She spent around 3.5 years working in the industry before joining RV College of Engineering as assistant professor in January 2007. She received her PhD from VTU for the thesis titled Morphological Analysis and Part of Speech Tagging for Kannada Language in 2013. Her research interests span natural language processing, information retrieval, data analytics, and engineering education. She has more than 25 publications to her credit in international journals and conferences. Madam has achieved many things. It includes coordinated and represented BMSC co-organizer at 14th International Linguistics Olympiad held from 25th to 29 July 2016 at Infosys Mysore. Contestants from more than 30 countries participated in this event. She is an IUCE IGIP certified engineering educator. Madam currently has two consultancy projects with Microsoft Research India. She is a life member of Indian Society of Technical Education. Madam hobbies includes traveling, learning classical dance, and Carnatic music. She successfully completed Vidvat exam of Bharatanatyam at the age of 17. She has visited US, Australia, and Europe. On behalf of VVC and Department of ISC, I heartily welcome you for this session, madam. Over to you.
Thank you. Thank you so much, sir, for that short and sweet introduction. I hope my audio is quite clear.
Yes, madam, it's clear.
Okay. Thank you, sir. At the first place, I would thank the organizers of this workshop titled Natural Language Processing for Beginners. I'm glad that I'm part of this workshop as a resource person. Right? And very good morning to everybody present here. I know this is slightly different because all the 3 days you've had sessions in the afternoon. So I guess we've broken that chain. We are having the session in the morning today, right? So I would first quickly tell you the plan that I have. I didn't see many on the thing as in the session, but I hope many would join us very soon. The session would be split into multiple parts. The first part is a quick recap of the fundamentals. I know you've been doing NLP for the past 3 days. I'll quickly rush through the perspective of how NLP is seen today, probably 10-15 minutes from now. After which I would actually want to know the audience, right? I know I'm live on YouTube, you have live chat, you keep giving questions, comments, but I can't see it. So the one way that I would want to interact with you is to do a quick game with you. And I'll tell you of how it works, the instructions, but I hope in under 15-20 minutes, I'll have most of the participants with me here. And with the permission of our organizers, I would say participants joining the game would be considered being part of the session. Yeah, added to the feedback that you give at the end of the session, I request, most of your friends who have not joined will join us soon. Right? After that, I will jump on to give you a quick demo of the basic NLP stuffs from a programming perspective. So I will run through code snippets, Python code snippets, to give you a brief introduction of how NLP subtasks work. That's kind of a hands-on session because I understand this is a workshop. Later, I'll split the remaining part of my talk into two things. One, which is the main topic for today, which is language modeling. So we will look into probabilistic language modeling and then move on to the last part of the session, which would be transfer learning, or the entire essence of how to build language models with transfer learning, right? So we will look at state-of-the-art research which is happening in the domain of natural language processing, right? So let's get started. So we've been communicating with machines, and this is how we have progressed. I understand computer science is a new branch of engineering, unlike civil, mechanical, which have decades of history. Computer science has been very recent. It kind of started off with machines which were half the room, punch cards being used in 50s, 70s, and in 80s, was the years when we were born. I'm sure we have, people of all ages here. So around 1980s, we had machines which could understand the context that we were telling, right? So we had a UI, we could type, ask questions and get answers. So that was in 1980s, but it was more of a command prompt type of thing, right? But today we have machines which understand us very well. As in, I talk to machine just the way I'm talking to my friend or my student or my colleague, right? So, so what you see here is today's chatbots or today's conversational agents, right? So Google Assistants are all over the place. Alexa, Siri, Bixby, right? All of these today use NLP, right? All are actually the result of the efforts of huge number of NLP researchers, practitioners, NLP engineers, who have got us to this date. So conversational agents added to NLP also have speech recognition, understanding the speech, the dialogue processing, information retrieval. There is text to speech, and added to all this, there is language analysis, right? So I'm sure most of us, even my younger son, is used to using these agents these days, right? So he wouldn't want to look at a clock, understand of how to read the clock, but would rather say, Alexa, what's the time, right? So that's easier. So NLP is into our day-to-day lives, right? So it was way back in 2011 where question answering systems did use a lot of NLP, and it was the highest point when IBM came up with Watson, and this was this game of Jeopardy in which a machine won against humans, right? So that was marked a very important day in the history of NLP, because you had machines beat humans, right? So at this point, I would thank the resources that I've used from internet to get these details and slides. Right, machine translation is also one of the applications of NLP. This is a snapshot of Google Translate. As you can see, there are so many hundreds of languages. You say this is the source language, this is the target language. You have translations happening across, different languages. Basically, this is NLP, right? Okay, I have a quick question. I hope I can have my participants give me the answer to this. Any idea of how many languages exist in the world today? Any wild guess? I can see the answers. I see the answers on my mobile, so you could try doing a guess. Is it around 1,000 languages across the globe? Because we are talking about language processing. Okay, do we have hesitant participants? Okay, it's around 6,000. right? There are 6,000 languages, and Google is looking at, enabling this machine translation for a good number of popular languages across the globe. And even in India, there are around 700, 750 languages just in India. Not all of them which have a written script, but that's a huge number, to be used in a single country. So, yeah, around 6,000. Thank you so much, Muralidhar sir, for that reply. Right. So, so machine translation would involve a lot of NLP, and as you would have guessed it, there's a lot of machine learning, deep learning happening behind the scene to help you translate from one language to another. This is one, not a complete list, a very short list of where NLP applications fit in and what are the core technologies involved in it. I'll look at the core technologies first. So this would involve language modeling, parts of speech tagging. We look at a sentence, every word in the sentence being given its parts of speech, trying to say whether it's a verb or a noun or a pronoun, things like that. We also look at syntactic parsing, where we say every sentence. Sorry, I'm talking only in the context of English as of now. So when I say syntactic parsing, every sentence has a rule that it should have a subject predicate, a noun phrase, verb phrase. So is it syntactically correct? Is it making some meaning? Is what a parser would check. Named entity recognition would look at identifying words in the sentence which refer to a person, a place, a location, thing, and a company, an institution. So that's NER in short. Word sense disaggregation is also a core technology or a core task, NLP fundamental task that is done, where we understand or look at the context to disambiguate of what the meaning of the word is, right? So we don't just judge the meaning of the word, but we judge it by the words around it, right? So that's word sense disambiguation. We'll look at more examples of it. Semantic role labeling is also a task which is under the semantics, right? So all of these become part of any of these applications on the left that you see. If you say you're doing information retrieval, you will have to do these tasks on the right? So they become the fundamental building blocks. So it could be dialogue systems, a chatbot being developed, information extraction. You could be looking at summarization, where you say, okay, you're being given a book, you're expected to summarize the essence of the book in a page, right? So that's summarization, and how wonderful, exciting it would be if if an algorithm does it for you. Right? Sentiment analysis, I'm sure for the past 10 years, we have been looking at it, movie reviews, reviews about restaurants on Zomato, things like that. There's a lot of sentiment analysis done, and take it from me, all of these would be part of such sentiment analysis. So NLP forms the intersection of two major fields where we say computational linguistics and machine learning. So when I say machine learning, it is more statistical, and computational linguistics is the essence of linguistics also being there. For example, an English professor would know the linguistic feature of it, right? So if we are building a NLP solution for English, I should know the linguistics, right? So the fundamentals, at least, it applies to any language as such. So the level of linguistic knowledge would become very important if you're looking at, tasks like morphology, lexemes, speech, and things like that. It will become even more deeper when you're looking at the semantics, the pragmatics part of the language. So if I say, we might have research scholars here in our group. So if you're looking at working on Kannada, not everybody can, should look up Kannada books now. Kannada grammar book itkondo Kannada pandit ragbeku annodilla. but because you may not be looking at semantics, but for the fundamental things, you will have to. Sorry for that. Yeah. So you will have to look at the morphology and lexemes, right? Quick recap of those fundamental things that I said. If you're looking at speech, you will have to look into the pronunciation modeling, the phonetics or the phonology, where you say this is an, and the words are looked as phonemes. But NLP usually would deal with text, so we don't look at the signal processing in NLP, right? The speech part. Mostly it is into text being given, and we looking at building a language model for a set of sentences for a corpora being given to us. So you look at tokenization being done, spelling corrections being done at the words level. When it comes to morphology, you look at morphological analysis where every word is morphologically analyzed. You try to figure out of what is the root of that word. You do tasks like tokenization. Every sentence, based on the spaces between the words, are identified as tokens. Lemmatization or stemming are also pre-processing tasks. I'm sure Pratibha ma'am on day 2 would have dealt with that. For example, stemming would mean removing the suffix. Lemmatization is also a type of stemming, but would do more trying to figure out the root. For example, gone, went, going will be lemmatized to the word go. Parts of speech, as you can see, it's the same sentence. This is a simple sentence where for every token that's being identified, you identify what is its parts of speech. So you say it is it's a verb, it's an adjective, noun, and things like that. After you've done with the parts of speech tagging, you will look at syntax parsing, where you look at, if you can see, this is the parse tree that's generated. You say this is the noun phrase, verb phrase, and a sentence has a noun phrase, verb phrase. So this is kind of very similar to what you might have studied under TFC, the formal languages and automata course, where we look at context-free grammars, rules being written. But it's not as simple as that, because we're talking about languages, not formal languages, right? So, but it's on similar lines. Moving ahead with respect to semantics, the tasks of NER, WSD come into picture. So you look at, is this syntactically correct, semantically correct? Is it making sense? So you kind of understand the semantics of any given sentence. So this is the next step, the discourse level. I think this should get us to the end of the first session. Yeah, so before I conclude this first part, this was just a quick review of NLP and fundamentals. So as I said, it's not just one field. There are multiple things coming together. It's machine learning, linguistics. When I say linguistics, there are a lot of many intricate things, nuances which come into picture. There's cognitive science, information theory, data science, because I said there's a lot of data corpora available, there's analysis to be done. So you have data scientists helping you. The domain knowledge, say, if you're working with medical data corpora, you will need the domain knowledge. So you will have political science, psychology, economics, education, many fields which are connected to NLP in one way or the other. Right? I'll pause here for a second. So, yeah, I request all the participants to take the mobile and on the browser, open any browser, click on or open this site which is called kahoot.it. I request all the participants to, to become interactive for some time with me, because I would want to know to whom I'm talking to, right? So let's play a game now. On your screen, you see this web page, which is called kahoot.it. I request all the participants to open this. Yeah. Let me know once you're ready. It is asking you to type a game pin. I will give you the game pin. You will enter the game pin and say enter. So that's when you get into the gaming part, the room where we will have this interaction. Yeah, can I have some of you put on the chat saying you're ready, you're on this page and you're waiting for the game. Yes, okay. We have Muralidhar sir there, okay. Okay, so on the screen, you will see the game pin, and this is the game pin that you will put on the mobile, or if you're using your laptop, wherever you opened your, browser, where you have the screen where you have to type the game pin. Please put it as 7835063. Okay, we have Vidyut who says is ready, Vijay is ready, and it's waiting for players. So please put the game pin and say enter. Okay, we have participants joining me here. We have Anjali, Vijay, and Murali. I know it's really tough to be in an online class like this. But yeah, I truly appreciate the efforts of teachers for the past 1 year. We have switched so very well from offline classes to online classes. Yes, we have the 4 participants, JP7. We have Gupta sir. 5. I think 5 more we could wait and then start it. Do we have Chaitra, Sonali also? That's because I see them on the chat window. I think 1 more minute we will wait. Otherwise, we'll go ahead with whoever is an active participant in this session. Right, I repeat, the instruction is open kahoot.it on a browser, on your system or your mobile or your laptop or your tab. You will see a screen where you have to enter a game pin, and on the game pin, please put it as 7835063. Okay. Then for me to start, I think, yeah, it's just 6 of you. I'll keep it very brief, but this is kind of a game where initial few questions are for me to know your background. Probably 4 questions, no marks for it. But after that, there are quick, short questions on NLP, right? I understand you've been attending NLP workshop for the past 3 days. This is your 4th day, so you would have known lot many things about NLP, right? So let's get started. The first question on the screen, you'll be timed, yeah, as in you have to choose the options on your mobile. The question is, just tell me who you are. Are you a faculty, or are you a research scholar? Are you a UG student, or probably if you might be a PG student also? I'm waiting for answers. So click on red, blue, yellow, or the green one. Yes, so I see all three of you being faculty. I think this was time. You took some time to tell me or choose the options on your mobile. That's fine. Yeah, that's fine. The problem is you will have to look at my screen also to find out the options, the meaning of the options. So yeah. Next question is also pretty simple. Don't worry. As in, you have to tell me the next one. Yeah. You're a faculty, you do programming. Which is your choice of programming? Is it C? Is it C++? Or have you switched to Python of late? I have two people who've given me the answer. It's okay. It's taking you time to answer. I have three of you give the answer. Oh, excellent. I have two people who say Python is your choice of programming language. Awesome. Java is also, we have a Java programmer also in the call today. There was no score here, that's just a scoreboard. I would want to know if you have completed any NLP course other than the workshop that you're attending today. Are you completely new, or have you done it before? So please put an S or a no. Okay. Yeah, we have beginners, so fine. So this is a workshop for beginners. We have beginners. We also have a person who has done NLP to some extent before. Nice. No scores yet. The last question, just to know, do you know Kannada? Now, for the rest of the session, for the next 1.5 hours that we will be together, Kannada Bharata Ilva. Or should I still stick on to English being my mode? Yes, ellarigu Kannada barutte santosha. So nice. Yeah, so we could continue. So now it's the actual quiz part where the scoring would start. You will have questions on the screen. You've got used to the tool now. Options can't sit there. You will have to choose the options, right? Very simple, basic questions about NLP, something which you have learned for the past 3 days. Okay? Don't worry, idral baro marks dependent agi certificates kododu athwa kodde irodu illa, because I don't have anyways all of them here on the screen. Yeah. So let's get started. Yes. So the first question is NLP andre enu, right? What is NLP? What would it stand for? You have time. This is a 30 seconds question. So take time, read the options, choose one of the options. Yeah, please be quick. Time up. Okay. There was only one right answer. Even ಸ್ವಲ್ಪ ನಿಧಾನಕ್ಕೆ ನೋಡ್ಬೇಕಾಗಿತ್ತು options ಅನ್ಕೊಳ್ತೀನಿ. The answer was natural language processing. The other options were also confusing. Yeah, sorry. Nature language processing or natural language process. Fact. So I have one person who gave me the answer right, and that's Anjali. Okay, kudos Anjali. You were the one who gave the right answer to the first question. So Murali Vijay Gupta sir can still make it. Let's move on to the second question. Second question of the quiz, which has scoring. Which of the below are NLP use cases? Andre applications of NLP yavyad? Facial recognition, speech, detecting objects in image, athwa text summarization. Which one do you think is a example of NLP or an application of NLP? Okay, good, bravo. All of you think text summarization is an NLP application. So yes, good. Let's get going. Yes, I still have Anjali on the top of the scoreboard. Good. But yes, others are also picking up. You have your scores. The other thing is, quicker the answer, more points that you will get, right? So let's get going. The next question, it's a true or false. What do you think is the process of converting a sentence or paragraph into tokens? Is it called stemming or is it different? Identifying tokens in a sentence. Is it stemming or is it something else? Okay, we have time, but we have all of you answer the question. Yes, it's not called stemming, it's called tokenization, right? Stemming would mean a suffix ತೆಗೆದ್ಬಿಡ್ತೀವಲ್ಲ ಈಗ affectionate ಅಂದಾಗ ಕೊನೆ part nate ಅನ್ನೋ ತೆಗಿತೀವಲ್ಲ, that is stemming, right? Awesome. 4 of you got it right. So let's see if Anjali is on the board. Yes, she's still on top of the board. JP7 is slightly behind, but you can make it. Right. I think 5 more minutes, we will finish this. What's TF IDF? You've heard this for quite some time since as part of the workshop. What does it do? Does it identify frequently occurring word or does it identify the important word? There's a difference between the two options that you see. The timer would stop in 4, 3, 2, 1. Yes. So no, please remember, it's not just the count. Andre ಒಂದು ಡಾಕ್ಯುಮೆಂಟ್ ಅಲ್ಲಿ ಬರೀ BMS ಅಂತ ಹಾಕ್ಬಿಟ್ಟು ಲೋಡ್ ಮಾಡ್ಬಿಟ್ರೆ ಅಥವಾ ವೆಬ್ಸೈಟ್ ಅಲ್ಲಿ ಹಾಕ್ಬಿಟ್ರೆ BMS ಸರ್ಚ್ ಸ್ಕೋರ್ ಜಾಸ್ತಿ ಆಗಲ್ಲ, right? So it's not just about the frequently occurring word, but it also depends on the inverse document frequency, right? So it's the importance of the word in the document. It's not just the count of the word. For somebody to become popular, they would have done web pages with lot of the required terms repeated. They would have had Google give higher ranking for such web pages. No, it's not that. Slightly different. Yeah, we didn't have anybody give the right answer there, so Anjali is still on the top. Next question on the board. NLP, there is a task which identifies people, organization in a sentence or paragraph. Adike ಏನು ಅಂತಾರೆ? Is it called lemmatization, NER, stop word removal? This is an easy question. I hope, I'm sure all of you will get it right. Look at the options, choose the right answer. You still have 10 seconds to go. Okay. Yes, perfect. As I said, all of you got it right. I think if you didn't make it with the timeline, net issues irbodu ಅಥವಾ ಬೇರೆ ಏನಾದ್ರು irbodu. That's fine. Yes, it is named entity recognition, NER. Okay, let's move ahead with the next question, which is not a pre-processing technique. NLP li yaudu pre-processing task alla of these options. Yeah. Okay, right? Sentiment analysis is an application. It's not a pre-processing technique. Perfect. All 5 of you have got it right. Kudos to everybody who made it within the deadline. Main challenge of NLP. Yak NLP kashta? POS tagging kashtana, tokenization kashtana, athwa ambiguity, sentence artha madkolod kashtana? What do you think, or is it all of these? I mean, it's with respect to the current date. Most of you thought it is all of these, about all of the options, but the main challenge, I said main challenge is actually ambiguity. Andre ಈಗ ನಾವು ಕನ್ನಡದಲ್ಲಿ ರಿಸರ್ಚ್ ಮಾಡೋದಾದ್ರೂ ಕನ್ನಡಕ್ಕೆ POS tagging ಮಾಡೋದು ಇವತ್ತು ಸುಲಭ, right? 8 years back when I did my PhD, or 10 years back when I actually started POS tagging, ಆ ಕಾಲದಲ್ಲಿ it was really tough, right? But ಇವಾಗ things, NLP has grown to a great extent where it's just a single line of code in Python. Yeah, we will see it very soon. One the line code bardu, I can split the entire document into tokens. I can identify parts of speech tagging. So it's not a tough task. The question of ambiguity is still a challenge, right? That's okay. Let's move ahead to the next question. Last 3 questions. What is machine translation? The options are quite confusing. Once you nidanakke nodi uttara kodi. Machine translation. Right. Yes, one of you got it right. It's not about ನಾನು ಮಾತಾಡ್ತಿರೋ ಕನ್ನಡನ ಬೈನರಿ ಮಾಡೋದು ಮೆಷಿನ್ ಟ್ರಾನ್ಸ್ಲೇಷನ್ ಅಲ್ಲ. ನಾನು ಮಾತಾಡ್ತಿರೋ ಕನ್ನಡನ ಇಂಗ್ಲಿಷ್ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಿ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಕೆಳಗಡೆ ಕ್ಯಾಪ್ಷನ್ಸ್ ಬರುತ್ತಲ್ಲ ಇನ್ ಇಂಗ್ಲಿಷ್, ದಟ್ ಇಸ್ machine translation. Okay, it's not English to binary or binary language of machines to Kannada. Illa, it's one human language to another human language. As I said, it was confusing. This is actually easy game to play for people who are playing the game on their mobile, and on the desktop or laptop they see the screen, right? That's fine. Yes, Anjali has a new competitor, which is Vijay. Yeah, let's get going. Named entity recognition, is it all about determining pronoun? Pronoun identify ಮಾಡೋದಾ ಅಲ್ವಾ? Is it true or false? Okay, it's not true. Named entity recognition, as I said, it identifies person. So Shambhavi works in B.M.S. It has to identify Shambhavi as the named entity, B.M.S. as the named entity, but not looking at pronoun mapping. Okay, let's go ahead. Yes, last question of this round of quiz, which is not related to NLP. Which field do you think is not related to NLP? Is it psychology, linguistics, machine learning, or is it history? This is just one answer. Right, 3, 2, 1. Yes, we have all the answers on the screen, but the answer is history. So one of you got it right. Psychology is also part of natural language processing. For example, let's say we are talking about speech analysis, speech recognition. There is a lot of emotions which you want to try to figure out from the speech, correct? So there's a lot of psychology, the background, emotion identification which you want to do with analytics or NLP. Athwa one text bardirodu, a text odadagle, you may be able to figure out of what state of mind that user might be in, right? So there's psychology. Right, I think time for us to know the winner of this quiz. Murali takes the 3rd place. Congratulations. And the 2nd place goes to Gupta sir. And the 1st place, as we had expected, is Anjali. I don't know if there's a delay on the YouTube, but yes, we have Anjali, Gupta sir, and Murali. Yes, it was a small group, but I hope all of you did enjoy going through this quiz. I think I'll switch back to the next phase. Any questions? I could pause here. As I said, I've logged in from my mobile as well. I can see the questions, not an issue. So you could post your questions if you have any at this point of time. Yeah. So let's move on to the next part. We're not halfway through yet with the session. It's just 11:40. The right, time as I had planned the 2 hours to be, right? So we are done with the first two things. To kickstart with the NLP terminologies with the quiz, we have got to know some things which were not clear or which we were confused. We kind of know things better now, right? So as I said, the pre-processing task is quite full-fledged these days, right? So on the screen is the online Python notebook on what is called Colab, right? So this sheet is prepared for beginners, for them to know how to initially start off coding, right? So I think I can increase the font size. I hope it's better now. So what you see is Python codes being written in the code section, and as I run it, you will see the result of it, right? So let's say you have a page, a Wikipedia page, which is about NLP, right? So it's a web page, there is data there, there is corpus, you would want to extract it, right? So I don't know if if the participants have done this before, but for beginners who think you haven't done it, you've done Python programming, but not from the context of NLP, this would be a good pointer to start off. So as you can see, I'm running this code snippet. I have used an API of Beautiful Soup, which does parse the web page, which I have mentioned here, and it prints the content, right? So if you can see, it has extracted the content of that page and gives it to me here, right? So you have got the corpus ready, and it's now ready for you to process. So when I say process, the pre-processing step, cleaning, tokenizing, stemming, lemmatization. Yes, so let's go ahead. So let's do the tokenization. I put it not for that web page, but for a simple string. If you can see, I say I like this book. There are spaces, so I would want my the splitter to understand that there are 4 tokens, and the 4 tokens are I like this book, right? Moving ahead, we will see of how I could use a regular expression. Regular expressions are very powerful in NLP, right, where you extract phrases or strings of your interest, right? So you say you would want to, okay, let's say I want to find out the mail IDs of all Vidyavardhaka College employees, the faculty, everybody. I will visit your website. I will extract all those things which have a mail ID at vvc.ac.in, right? So I could write a code and I could retrieve all the data. So if you could see, I've looked at extracting mail IDs given a regular expression. So this is the result part, right? Another pre-processing step is to convert the entire data into lowercase, right? So before I do processing, I wouldn't want to differentiate between uppercase, lowercase, right? So there are applications which do take, which are case sensitive, but things which are not, you could convert everything to lowercase. So Python does it right away. So this is the input where, if you could see, there are 7 sentences where every word in that was converted to lowercase. Okay. Removing punctuation is the also very frequently done pre-processing task. So if you could see, I have intentionally put this full stop, exclamatory, double quotes, right? So so everything is removed, right? So removing stop words. I'm sure you would have known stop words. Okay, we have an error here. Okay, so NLTK, I would want to draw your attention to NLTK. This is a toolkit, a popular toolkit in Python for natural language processing, which has all the things that you want to do, built in, easy for you for stop words. So English stop words is a huge list. Is, the, on, from, Kannadadallu there are stop words. So a list of stop words. So if you give it, it'll remove all stop words and it'll only give you the tokens which are required. So there's an error. We may want to, in the interest of time, I'll skip this task of debugging this part. This is standardization where of late, people talking about, on social media or while chatting, they happen to use abbreviations, right? So, your, YOUR type madala, they'll just say your, right? So we understand, but how can a machine understand? So you will do what is called standardization at that for that task. Spelling correction, as I said, is an easy task. There's something called text blob. So you import the necessary things and you say you want to correct, let's say you misspelled message, you misspelled service here, right? So you want to correct it, it'll correct it for you and it'll say, yes, this is the right. So spell checker, I'm sure, is one boon for most of us who use Word, as a feature. We truly appreciate spell checkers. Tokenization, let's go ahead to see of how tokens are identified. So this is my favorite animal is, right? So after trimming, right? So that's tokenization. Stemming, fishing, either fish, fishes, everything will become fish, right? So if you could see, I like fishing, after stemming has become I like fish, I eat fish, and fishes has become fish, right? So lemmatization is similar to stemming. I think we could go ahead. Lot many things. So this is how you could visualize the count of different words existing in a document. So we visualize it with a Python tool called matplotlib, or it could be a word cloud. This is TF-IDF, right? So let me see if this works. Yes. So TF-IDF is just a call to this TF-IDF vectorizer. So given a text, if you could see, it counts and gives me the scores of which is the most important word in the document, but not the most repeated word in the set of three sentences that I've given. Okay. Noun phrases, I think I could share this with the workshop organizers where, you look at how POS tagging could be done, or extracting entities, or it could be even, doing sentiment analysis with just a short code snippet like this. So you say, I like this phone, or the review where the TV is not good. So you see that the polarity of the first review is positive, but let's say I come and this part. Let me run the code for the second review. I should see a change in the polarity, right? So you see that, and there's disambiguating text. This is what I said was very important, or something which is still a challenge, where when you use the term bank, it could be a river bank, or it could be the financial bank that we are referring to. So I went to the bank to deposit my money. I know what is the bank the term that's being referred to. Or even machine translation. We will do this last part where I have a text in German and I say translate this. Library Ghostlet will do it for me. So it says yes. Guten Morgen in English would mean good morning, right? Yes, 10 minutes. I think we have. Quickly gone through this NLP fundamental steps being done using Colab, right? Or it need not be Colab. If you have Anaconda installed on your system, you could have these Python codes run, right? Time for me to go to the next part. Next. Yeah, the next. Okay, if there are any questions, I would request you to post it now, or you could keep it on hold. Okay, I have a couple of questions. I think I'll, with the permission of the organizers, I will take the questions now. In named entity recognition, is it possible to identify type of things using names? Type of things as in, yeah, I would want more details or an example from Muralidhar sir about this question. If you could give me a sentence and tell me, I'll be able to understand this question. Kirti Kumar says, instead of regular expression, is there specific functions to do tasks of pre-processing? As I said, sir, regular expression is the most fundamental thing. Yeah, as there are a lot many things. So initially in 1980s, when people wanted to communicate with systems, they were doing regular expressions. But of late, you don't do regular expressions. There are a lot of machine learning techniques well built, which help you do pre-processing. But yeah, for a language, the language like Kannada or any Indian language which you think is a resource poor, we could start our work with regular expressions. Kirti Kumar sir. Right. So since Kirti Kumar sir asked that question, I will bring this slide where initially NLP systems were rule-based. Right, so all the things that you had to do, it could be machine learning translation or conversation enabled systems, you had to do it rule based, right? So as I said, regular expressions are rule based systems. So you say, okay, if this is the rule followed, I want to go to. You say go to admele ಒಂದು noun ಇರಲೇಬೇಕು. That's when you say syntactically the sentence is correct. So you had to hard code the rules. But 1990s people moved to machine learning, the statistical NLP. Linguistics was considered, but people said, okay, let's have statistics. If somebody gives me 1 million sentences in English, I will be able to understand English. I will enable my system to learn the English language, right? So that's when statistical NLP started, and that's when machine translation. That's a case study here. So they built a language model on the source phrases that they used to map it on to target phrase, but how? Using the features which were part of the machine learning model or the language model, and how were these features being learned was the challenge in statistical NLP. I'm sure yesterday's talk you would have learned of how to do feature engineering, right? So that was in 1990s, but today things have changed. 2010 or 20 of late, yeah. From machine learning, people have moved to deep learning, right? So we don't just look at probability, in building language models, but we look at deep learning algorithms being used, a lot of neural networks, neural language models being used to help us do all the tasks of NLP. Right? So current state of the art NLP, from a statistical perspective, doesn't further look about probability based models, but about deep learning based models, right? So if one of the questions that comes to your mind is NLP ಮಾಡಬೇಕು ಅಂದ್ರೆ deep learning ಮಾಡಲೇಬೇಕಾ? My answer would be yes, yeah, because if you are a researcher, or if you think you would want to take up research in the domain of NLP, you have to know Python, you have to know deep learning. So deep learning, NLP go hand in hand these days. So doing a full-fledged course on deep learning will surely help you, take your journey in NLP research easier, moving forward. Yeah, and this is any problem statement. Andre classification problem irbodu, sentiment analysis irbodu, any problem that you take in NLP, you could be applying deep learning algorithms to it. Right. Okay. Thanks for that question, Muralidhar sir. Your question is B.M.S andaga. Can you identify it as a technical institute? Yes. Rule-based system alli, what we do is everything in capital letter. As in, if you say, I went to MG Row today, I'll MG capital baritira English alli, so you will know, okay, ಇದು special, ಇದು named entity anta gottagate. But when we are talking about deep learning models, andre na heldalva, let's say there are 10 million sentences about a domain, the education domain being given to this deep learning system. It learns alli nee BMSc int kottaga, the chances that it will identify BMSc, VVC or IIT Kharagpur as an academic institute is higher. Yes. So may not be possible with no fundamental systems, but with deep learning systems, you can still identify BMSc, for example, as an institute, as an education institute. Again, domain knowledge comes into picture when we're talking about such things. Right. So with that context, the next part of my talk will be split into two phases. One, which speaks about probabilistic language models. Andre 1990s alli rule-based bit to probability-based systems bandi. What is the advantage of it, or what, and later what are its drawbacks, and how have we moved to transfer learning? That will be the last part of my talk. Right? Okay. Yeah. So let's look at what is language modeling. I mean, you've heard this before, but formally, for me to put it, it's assigning probability to a sequence of words. Ashte. Equal deep learning alli irbodu, it is seen as predicting the next word. Athwa a model which takes in a sequence of words, one word go, one probability kodbeku, right? For example, let's take a language model which predicts completion of a sentence. Andre ಈಗ ಎಷ್ಟು ಮಟ್ಟಿಗೆ ಹೋಗ್ಬಿಟ್ಟಿದೀವಿ ಅಂದ್ರೆ ನಮ್ಮ ಮೊಬೈಲ್ ಅಲ್ಲಿ ವಾಟ್ಸ್ಆಪ್ ಅಲ್ಲಿ ಟೈಪ್ ಮಾಡಬೇಕಾದ್ರೆ it gives suggestions, right? So if I'm typing to my HOD, I will be late to college, ma'am, ಅನ್ನೋಕ್ ಮುಂಚೆನೆ it will give you madam, because most of the conversations with my colleagues on WhatsApp, I might have typed madam, sir for every sentence that I would have put, right? So it kind of learns on the spot. So Android OS we have the application is so intelligent that it can predict, right? So, and it's not just prediction based on somebody else typing history. It's, it's on my phone, it's my WhatsApp account, so it knows the way I type things, right? So coming back to this example on the screen, so a language model supports predicting the completion of a sentence. For example, let's say, please turn off your cell, you know what the next word should be, right? And you know it, you will build a language model which knows what should be the next word, right? So you could say cell phone. So cell phone andaga, phone again, there's a higher probability. So your model says, okay, phone na first suggestion anta kodana, ಆಮೇಲೆ ಬೇರೆ suggestions ಕೊಡೋಣ, right? So it has to rank the suggestions, right? Recommendation. Or your program does not work, your program does not scale, your program does not look good, right? Look good would be probably with a lower priority than does not work. Work might be the next suggestion, right? So your language model helps you do this, right? So predictive text input systems, as I said, can guess what you're typing and will give you the right choices to complete it. So prediction or predicting the next word is not just an application. Language models are used in other NLP applications also. For example, machine translationally, let's say Kannada sentence kottidira, that Kannada sentence is to be converted to English, right? Now, the language model should be able to give a higher probability to a proper English sentence than to an improper English sentence. For example, if I say high winds tonight or large winds tonight, so on ಸ್ವಲ್ಪ a large winds ಅನ್ನೋದು ನಮ್ಮ learning ಅಲ್ಲಿ ಇರಲ್ಲ, right? So it will get a lower probability than the high winds. So my machine translation will say high winds tonight is the exact English translation of Indu Ratri Birugadi Baruttade, right? Something like that. Spelling correction, yes, there's a lot of context the language model has to figure out with respect to spelling correction. The previous demonstration that I showed, it was an easy task, but behind that API, there's a lot of things that's happening, right? For example, if you have a spelling mistake of minutes here, it understands that it has to correct it because minutes is to be spelled as M-I-N-U-T-E-S, right? And not M-I-N-U-E-T-E-S, right? So the probability or the score, as I should say, given would be more, right? So another application is speech recognition. So, not everybody speaks the sentence the same way, right? So there's something called accent, pronunciation differs. So I saw a van. So machine should figure out of what is that, right? So it cannot interpret it as eyes of an, right? No, it wouldn't, right? Because it knows that's really a bad English sentence, right? So it wouldn't. So it'll take the probability of the right sentence. And how does it do it? Yeah, we will see. And for that, yeah, the applications could be language models being probabilistic language models being used in summarization, question answering, and many more. The list goes on. You've done this earlier, but a quick recap. N-gram models were the initial probabilistic models, right? So, when the sentence kotre, ಒಂದೊಂದು word ನೋಡ್ಲಾ ಅಥವಾ ಎರಡೆರಡು at a time ನೋಡ್ಲಾ ಅಥವಾ ಮೂರ್ ನೋಡೋದ ಅಂತ. This was called unigram, bigram, or trigram. People actually moved ahead to build 4-gram, 5-gram systems, but after some time it got saturated. So given a sentence, you split it into, feed it to n-gram models. So when I say, please turn off your cell, it has taken all the, 6 words together and then predicts the phone might be the next property. So it estimates probability, not just seeing a word, which is unigram, but it sees the context. So one word hinde nodidre bigram, ಎರಡು word hinde nodidre trigram, right? So number of parameters required grows exponentially. If you add more words of the prior context. So n-gram will always use n minus words to understand the prior context. So as I said, unigrammarly bari one word ನೋಡ್ತೀವಿ, bigrammarly phone suggest ಮಾಡಕ್ ಮುಂಚೆ ಅದ್ರ ಹಿಂದೆ ಇರೋ cell ನೋಡ್ತೀನಿ, ಅಥವಾ trigrammarly what is the probability of seeing phone given that you have already seen your cell. You try figuring out that. Okay, n-gram formulae, I put it only for reference here. It's built on the chain rule. It says word sequences is seen as a set of words, and then you apply chain rule and you say it's a product of the probabilities. Bigrammarly, it's a product of all probability of wk occurring given wk minus 1 occurred just before it. So it's a product. It could be approximated for any gram, but this is multiplication. Alva, things have, people have converted this to convert this multiplication, this chain rule to an addition. So they take logs and they add up the terms and finally calculate the probability of the next word, right? Probability ಪ್ರತಿ ಇದು ಮಾಡಕ್ ಪೇರ್ಸ್ಗೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಾಗ ಏನ್ ಮಾಡ್ತಾರೆ, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ conditional probability, they kind of estimated based on relative frequency. So at the end of it, that probability comes down to counting words. So in the corpus, they count of how many cell phones occur together and how many cell occur together. So say cell phone ಅನ್ನೋದು 100 ಸಲಿ ಇದ್ರೆ, ಬರೀ ಸೆಲ್ ಅನ್ನೋದು 1000 ಸಲಿ ಇದ್ರೆ, it is 100 by 1000, right? Because you've 100 times seen cell phone together and 1000 times you've seen cell alone in the entire corpus. So that's the probability. So it comes down to counting the pairs, counting the word sequences. Added to that, we'll see an example where every sentence start and end we put tag, an additional tag to mark the beginning and ending of the sentence. So let's look at this. I picked it up from the textbook of natural language processing by Jeffersky, a classical book for NLP. So if you're starting, this should be the book that you should refer to. Statistical NLP. This is also a textbook in our college when we teach NLP. So let's say we have a sentence, I want English food. I'm trying to figure out, is this sentence correct or I want Chinese food correct? So what I would do is, if you could see, I've added this tags to the left and at the end, and I say I calculate the probability. The probability of I occurring at the beginning, the probability of I occurring just before want, conditional probability. So ella calculate ಮಾಡಿ, I find out what is the product. So for the first sentence, you see that the probability is 0.00, 4 zeros followed by 3 1, and this is I want Chinese food again, it is 0.3019, which means the probability of this sentence is more than the first sentence. Or technically, this is a proper English sentence, right? So the language model does this probability calculation, right? So language model built ಮಾಡೋದಕ್ಕೆ we should have a corpus. Let's say I'm looking at supervised learning. I will have to split my entire corpus into 3 parts. Excuse me. One, the major part of it would be called training data. The second part would be called held out data. This is also called validation data. The last part would be test data. This is machine learning, right? So what you would do is train the system on the training data, test your, the parameters or the weights learned with the validation. So validation data use madkondu, you will change your parameters, you will change your or you will improvise your learning. So that's held out data. But test data is something which you haven't seen till now, right? So Test data is the finance data which you get it on the spot when your application is being run, by the client, and your model will perform on that test data. And that's the main evaluation part, right? So, okay, I'll go by each of these points. So, model can be evaluated. Okay, we have. Okay. So, model can be evaluated based on its ability to predict the right word, and ideally, you would want the test data to be very similar, not the same. Take it from me. Test data iro data, agle training data iralla. Khandita. Athara idre, the accuracy of your system would be 100%, but it wouldn't happen. But it should be at least representative of the actual world data. Yeah, that's what we expect. Test data, newspaper domain allirodu, training data, education domain allirodu, it wouldn't scale, it wouldn't perform, right? So you would want them at least to be in the same domain. And as I said, the model adapts. There's adaptation where it learns from the training data, improvises its weight with the validation data, and performs or gives you the evaluation metric for the test data. The other big question is unknown words. Data training data illero words ಅಥವಾ ನಿಮ್ಮ ಡಿಕ್ಷನರಿ illero words test data ಅಲ್ಲಿ ಬಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? These are called out of vocabulary words, OOV. What you would do is adakond special tag kodtivi saying it's an unknown word, and it will replace the first occurrence of each word of that word as UNK. Yeah, that's with respect to POS tagging. Perplexity is the evaluation metric, right? So it's the evaluation metric when I'm talking about how good did the language model fit into the test data. Andre sarigidya ilva, right? So I mean, let's say you have done unigram, bigram, trigram. Yav sari hoytu, yav sari hoglilla anta tilkoloke perplexity is one of the evaluation metric. So what would this perplexity do? It will normalize the number of words and it will take the inverse, right? So that's the formula. Don't worry about the formula. So a sample evaluation on Wall Street Journal vocabulary of 38 million words. So it was shown that unigram score was 962, 170 for bigram, and 109 for trigram. So as you can see, lower the perplexity, better the language model is. So il bandiro 109, you would say trigram language model is better than the unigram one. Okay. Right. So does that mean making it 4 gram, 5 gram help agatta? May not be, right? So we will see that very soon. Smoothing is also one of the most important things which you do in probabilistic language modeling, because there are a combinatorial number of possible word sequences, right? So Englishly it's better. I mean, you say, I go to school, is fine, because if you say school go I, you know it really well that it's technically wrong. But Kannadadalli it's even more tough, because ನಾನು ಶಾಲೆಗೆ ಹೋಗುತ್ತೇನೆ, ನಾನು ಹೋಗುತ್ತೇನೆ ಶಾಲೆಗೆ, ಶಾಲೆಗೆ ನಾನು ಹೋಗುತ್ತೇನೆ. I mean, lot many things, you rearrange the word sequences, it's still technically syntactically correct, right? So so you may not have all possible word sequences, combinations of word sequences in the training data, combinations which may have never occurred in training. The MLE algorithm will assign zeros to such parameters, right? So zero adaga enagutte, a perplexity level 1 by 0 agbiಟ್ಟು infinity ಬಂದ್ಬಿಡುತ್ತೆ, right? So you don't want your perplexity score to be towards infinity, right? So what we do is we smooth that, probability score, and we add 1. It's called advanced smoothing, where this formula of bigram, if you have seen before, Ali, it was just count of wn minus 1 wn and wn minus 1 in the denominator. If you could see, I'm adding the 1 to the numerator, and v, which is the total number of n minus 1 grams. Basically, the vocabulary, ED document na bigrams madadmele, atra bigrams ಎಷ್ಟು ಬಂತು, that's capital V. Adana add ಮಾಡಿ, I will make sure, there is smoothing being, and this is the most simplest way to do smoothing with n-gram models. There are other smoothing techniques as well, good Turing, interpolation. You may take time to learn what these are. Know the background of how it works, right? ಒಂದು ಥರ ಮಾಡಿದ್ರೆ ಕರೆಕ್ಟು, ಇನ್ನೊಂದು ಮಾಡಬಾರ್ದು ಅಂತ ಖಂಡಿತ ಇಲ್ಲ, right? So as I said, perplexity seemed to be coming down, becoming lesser with the value of n increasing, but the ability to estimate accurate parameters, will go bad if you increase n. And people usually look at combining n-gram, trigram together. Yeah, and n-gram, trigram andaga, I'm talking about the word level n-gram models, right? So it could be even at character level, right? So adanna nan helilla. So the general approach is to combine a bigram model with a trigram model and build your language model. So your language model need not be just bigram or need not be just trigram, right? So it could be a combination. I haven't touched upon the other terminologies here. I think we had Roshan sir give you examples of how TF IDF is calculated and things like that. So adanna nanu repeat madilla. I will stop the probabilistic language modeling task here and move on to transfer learning. Questions, if any? Okay, I hope I have kept you awake.
No questions, madam. Can carry on.
Okay, yeah, thank you, sir. Right, so this is the last part. I mean, ivattu NLP ಏನಾಗ್ತಿದೆ, right? I know the workshop says NLP for beginners, but you begin today, you have to work in the current scenario. History ತಿಳ್ಕೋಬೇಕು, but ಈಗ ಏನಾಗ್ತಿದೆ, state of the art ಏನಾಗ್ತಿದೆ ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ, you will be able to work from now on, right? So I know this might be too much if you think you are a beginner, but keep it as one reference. Don't worry if you think it's too technical. Keep it aside, but this is for you to know, because any research that you want to start, you would want to know, or you would want to do literature survey, right? So you don't want to reinvent the wheel, alva? So agले 10 ವರ್ಷದ ಹಿಂದೆ ಆಗಿರೋ ಕೆಲಸನ ಪುನಃ ಈಗ ಮಾಡೋದ್ರಲ್ಲಿ there's no point. So you would want to contribute to the research world, and you would want to know what people across the globe are doing, right? So with that, I would want to move on to tell you of what is transfer learning or the application of deep learning in NLP today, right? Okay. It's around 20-25 slides, but most of it is taken from the source, which I found online, from a team which is working on transfer learning and making it open source. That's the best part. So it's a team of 4 people from various companies coming together: Sebastian Robert, Matthew Peters, Swabha, and Thomas Ulf. They're all NLP researchers who happened to do a tutorial on transfer learning during 2019. The slides, the collab, and the code. Yeah, as you can see, the entire code of how to do transfer learning, it exists. It's open source. It's for us to understand of how we could use it and also contribute back to the open source society, right? So all thanks to these people who helped me learn personally of what is the state of the art transfer learning. Okay, now let's understand of what is transfer learning. Like, yenid, right? Okay. Traditional machine learning till, as I said, 2010 or mid 2010 was like this on your left, right? So, sentiment analysis ಮಾಡಬೇಕಾ? Okay, ಅದಕ್ಕೊಂದು ಕಾರ್ಪಸ್ ಇದೆ, ಅದಕ್ಕೊಂದು supervised learning model ಇದೆ, ಅದನ್ನ I give and there is a language model generated. Okay, fine. Let's say there's a question answering system which I want to build, that is task 2. Adake, I will do one set of data collection, I apply a machine learning algorithm to it, and I have a language model which has learned the system and is ready for people to use it as a question answering system. So yeah, that's task 2. Similarly, task 3, so there are different language models which for specific purposes. So one language model which works for sentiment analysis, one language model which works for summarization, and one language model which works for, let's say, text to speech. Yeah, all different. That was machine learning, traditional machine learning. In transfer learning, what I do is the language models which have been built till date is used to learn or to solve a new problem. Andre, for example, there's a language model which does sentiment analysis very well. You also know a language model which does summarization, these triangles, let's say. Using these two language models, you have a knowledge, a repository, a system which will help you solve the problem of what? Let's say text to speech. How does it do it? It was done using transfer learning, right? It's something like this. It's 9 in my family, right? So, cooking is the most toughest task. So we have a cook, right? So before we hired a cook, my mother-in-law had to take a choice, right? So there were 2 people who came saying they want to be working as cook at my place, right? So one person, ಒಬ್ಳು ಅಡಿಗೆಯವ್ರು ಹೇಳಿದ್ರು, ನಾ ಇಲ್ಲಿವರೆಗೂ ಅಡಿಗೆ ಕೆಲಸ ಮಾಡಿಲ್ಲ, ರೈಟ್? ಸೊ ನನ್ಗೆ ಅಡಿಗೆ ಕೆಲಸ ಗೊತ್ತಿಲ್ಲ, ಬಟ್ ಐ ಆಮ್ ಎ ಕ್ವಿಕ್ ಲರ್ನರ್. ನೀವ್ ಹೇಳ್ಕೊಟ್ಟಿದ್ದನ್ನ ಬೇಗ ಕಲ್ತ್ಕೊಂಡು ಮಾಡ್ತೀನಿ. ದಟ್ ವಾಸ್ ಕುಕ್ ನಂಬರ್ 1. Okay, without experience, but was ready to learn from the scratch. The second cook who came to be employed at my place was somebody who said, Amma, ನಾನು ಅಡಿಗೆ ಬರುತ್ತೆ, ಬಟ್ ನಾನು ಇದಕ್ ಮುಂಚೆ ಇದ್ದವ್ರ ಮನೇಲಿ ಬರೀ ಸೌತ್ ಇಂಡಿಯನ್ ಆಂಧ್ರ ಸ್ಟೈಲ್ ಅಲ್ಲಿ ಮಾಡಿಸ್ತಾ ಇದ್ರು, ನಾರ್ತ್ ಇಂಡಿಯನ್ ಎಲ್ಲ ಹೇಳಿದ್ರೆ ನಂಗೆ ಬರಲ್ಲ, ನೀವು ಸೌತ್ ಇಂಡಿಯನ್ ಮಾತ್ರ ಮಾಡೋದು ಅಂದ್ರೆ ಐ ಕ್ಯಾನ್ ಜಾಯಿನ್, ರೈಟ್? ಸೊ ದೇರ್ ಆರ್ ಅದರ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಸ್ಯಾಲರಿ, ಅದೆಲ್ಲ ಇಟ್ ವಾಸ್ ಸೇಮ್ ಅನ್ಕೊಳ್ಳೋಣ. ಸೊ ಫಾರ್ ಮೈ ಮದರ್ ಇನ್ ಲಾ ನೌ ಟು ಡಿಸೈಡ್, ಟೆಲ್ ಮಿ whom should she choose? This cook who knew nothing but was ready to learn, ಇನ್ನೊಬ್ರು who knew only certain tasks, not all tasks, right? So she had to take a call. Right. So I think I'll take this a quick poll with the participants. Whom would you choose? Nimage en ansate? Cook 1 agboda athwa cook 2 agboda? Cook 1 whom you think namag ಏನೇನ್ ಇಷ್ಟ ಅಡಿಗೆ ಎಲ್ಲ ಹೇಳ್ಕೊಟ್ಬಿಡ್ಬೋದು, ಅದೇ ಅಡಿಗೆ ಮಾಡಿಸ್ಕೋಬಹುದು, ನಮ್ ತರಾನೇ ಮಾಡ್ತಾರೆ ಅನ್ಸುತ್ತಾ? ಅಥವಾ ಈ ಬರೀ ಆಂಧ್ರ ಕರ್ನಾಟಕ ಸ್ಟೈಲ್ ಅವ್ರು ಕರ್ಕೊಂಡ್ ಬಂದು ಅವ್ರಿಗೆ ನಮಗ್ ಬೇಕಾಗಿರೋ ನಾರ್ತ್ ಇಂಡಿಯನ್ ಸ್ಟೈಲ್ ಹೇಳ್ಕೊಡ್ಬೋದು ಅನ್ಸುತ್ತಾ? Okay, Muralidhar says cook 1. Okay, Vijay also sir also agrees with cook 1. ನಮ್ ಸ್ಟೈಲ್ ಹೇಳ್ಕೊಟ್ಬಿಡೋಣ, ಹೆಂಗಿದ್ರು ಏನು ಗೊತ್ತಿಲ್ಲ, ಇಷ್ಟು ಸಾರಿಗೆ ಇಷ್ಟು ಉಪ್ಪು ಹಾಕ್ಬೇಕಮ್ಮ ಅನ್ನೋ ಬೇಸಿಕ್ಸ್ ಇಂದ ಹೇಳ್ಕೊಡೋಣ ಅಂತಾರೆ. ಓಕೆ, okay, any other question? I mean, any other interested participant who would want to reply? Okay, fine. So you would say cook one, andre ಹೇಳ್ಕೊಡೋಣ ಫ್ರಮ್ ದಿ ಸ್ಕ್ರಾಚ್. ಬಟ್ ಎಷ್ಟು ದಿನ ಬೇಕು ಹೇಳ್ಕೊಡಕ್ಕೆ ಅಲ್ವಾ? ಅವ್ರನ್ನ ಟ್ರೈನ್ ಮಾಡಕ್ಕೆ ನಮ್ಮ ಅತ್ತೆಯವರು ಅಡಿಗೆ ಮನೇಲಿ ಅವ್ರ ಜೊತೆನೆ ನಿಂತ್ಕೊಂಡು ಮಿನಿಮಮ್ 1 ತಿಂಗಳಿಂದ 1.5 ತಿಂಗಳು ಬೇಕು. ಅವ್ರಿಗೆಲ್ಲ ಐಟಮ್ಸ್ ಹೇಳ್ಕೊಟ್ಟು 9 ಜನಕ್ಕೆ ಇಷ್ಟ ಅಡಿಗೆ ಮಾಡ್ಬೇಕು, ಇಷ್ಟ ಚಪಾತಿ ಮಾಡ್ಬೇಕು, ಹಿಂಗ್ ಮಾಡ್ಬೇಕು ಅಂತ ಹೇಳಕ್ಕೆ 1 ರಿಂದ 1.5 ತಿಂಗಳು ಬೇಕು ಟ್ರೈನಿಂಗ್ ಟೈಮ್ ಅಲ್ವಾ? ಬಟ್ ಲುಕ್ ಅಟ್ ದಿ ಸೆಕೆಂಡ್ ಸಿನಾರಿಯೋ, ಅಂದ್ರೆ ಕುಕ್ 2 ಪ್ರಿಫರ್ ಮಾಡಿದ್ರೆ ಅವ್ರಿಗಾಗ್ಲೇ ಒಂದು ಫಂಡಮೆಂಟಲ್ ನಾಲೆಡ್ಜ್ ಗೊತ್ತು. ಅಂದ್ರೆ ಒಂದು ಪಾತ್ರೆ ಸಾರು ಮಾಡೋದಾದ್ರೆ ಆ ಸಾರ್ಗೆ ಇಷ್ಟು ಉಪ್ಪು ಬೇಕು ಅನ್ನೋ ಫಂಡಮೆಂಟಲ್ಸ್ ಗೊತ್ತಿದೆ ಅಲ್ವಾ? ಅವ್ರಿಗೆ ಪಲ್ಯ ಮಾಡೋದು ಗೊತ್ತಿದೆ, ಬಟ್ ನಾರ್ತ್ ಇಂಡಿಯನ್ ಪಲ್ಯ ಮಾಡೋದು ಗೊತ್ತಿಲ್ಲ ಅಷ್ಟೇ, ರೈಟ್? ಸೊ ಸಮ್ ಫೈನ್ ಟ್ಯೂನಿಂಗ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ ದಿ ಸೆಕೆಂಡ್ ಕುಕ್, ರೈಟ್? ಸೊ ಅವ್ರಿಗೇನ್ ಹೇಳ್ಬೇಕು, ನಾರ್ತ್ ಇಂಡಿಯನ್ ಆದ್ರೆ ಗರಂ ಮಸಾಲ ಹಾಕಮ್ಮ, ಇಂಡಿಯನ್ ಅರ್ಶನ, ಇದು ಫಂಡಮೆಂಟಲ್ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಸೌತ್ ಇಂಡಿಯನ್ ನಾರ್ತ್ ಇಂಡಿಯನ್ ಹೇಳ್ಕೊಟ್ರೆ ಸಾಕು ಅಲ್ವಾ? ಸೊ ದ ಟ್ರೈನಿಂಗ್ ಟೈಮ್ ಈಸ್ ಲೆಸರ್ ಇನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಲರ್ನಿಂಗ್. ಸೊ ಟ್ರಾನ್ಸ್ಫರ್ ಲರ್ನಿಂಗ್ ಇಸ್ ಮೈ cook 2. Cook 1 is my traditional machine learning. So what is the advantage? The second cook comes with an advantage of experience, right? ನಿಮಗೆ 1.5 ತಿಂಗಳು ಅವ್ರ ಜೊತೆ ನಿಂತ್ಕೊಂಡು ಟ್ರೈನಿಂಗ್ ಮಾಡಕ್ ಆಗಲ್ಲ, right? Let's say you have other things to do, you are going for work, you don't have time to train them, you will take the second cook. That is transfer learning. Okay, there are pros and cons. I mean, I'm not denying the fact that traditional machine learning is all with disadvantages or transfer learning is with all advantages. I'm just trying to give an analogy from our day-to-day life to this scenario of traditional machine learning and transfer learning. I hope we kind of got the distinction, the difference, but yes, we still have to look at the pros and cons. So let's go ahead. Why transfer learning in NLP? NLP yak madbek? Actually, transfer learning another, it's not new. It's kind of new in NLP of late, but it's kind of a very fully fledged approach in image processing, right? So how do you think people build face recognition systems? Nam huduguru 6ML 5ML face recognition systems build madvi, data collect madadvi antare. How do they do it, right? It's all about transfer learning in images. There's something called ImageNet, which is kind of a repository, a knowledge which was trained on millions of images, right? Millions of images of all types. So our ImageNet use ಮಾಡಿದಾಗ nim training ಗೆ for your task you will have to only put a smaller data set for it to learn, right? You don't have to look at lot many parameters, right? So there's something which is ready for you to use, which is given, and fine tuning adaptation is what is required, right? So it's a very old, comparatively older technique in computer vision. NLP people are using it. So many NLP tasks, they share common knowledge about a language. So linguistic representation, structural similarity. I'm sure you understand Kannadagu Englishgu structural similarity illa. But if I say Kannada Tamil or Kannada Telugu, there's a lot of structural similarity which you can encash with transfer learning, right? And if you have tasks which can inform each other, so syntax, semantics, they go kind of hand in hand. So you may want to use transfer learning for such tasks. And as I said, annotated data is very, very rare. English ge sigutte, Kannadakke sigalla, right? So Kannadakke sigalla, but Hindi sigtide annodadre, if you think you have a system which is trained for Hindi, if you can map it, fine tune it, use it for Kannada, that is excellent, right? So you kind of reusing, with transfer learning. So annotated data is very rare. ಈಗ ನೀವು ಕನ್ನಡದಲ್ಲಿ ರಿಸರ್ಚ್ ಮಾಡಬೇಕು, ಆನ್ಲೈನ್ ಯಾವ್ದಾದ್ರು ಡೇಟಾ ಸೆಟ್ ಇದೆಯಾ, tagged corpus ಇದೆಯಾ ಅಂತ ಹುಡುಕಿದ್ರೆ ಖಂಡಿತ ಸಿಗಲ್ಲ. I mean, there are very few researchers who might have put things on GitHub ಅಥವಾ IIT Hyderabad ಅಥವಾ CIIL, although they make data available, but it may not be sufficient for your work. So ನಿಮ್ಮ ರಿಸರ್ಚ್ ಜರ್ನಿಲಿ 1 ವರ್ಷ 2 ವರ್ಷ ಬರೀ ಡೇಟಾ ಕಲೆಕ್ಟ್ ಮಾಡಕ್ಕೆ ಉಪಯೋಗಿಸ್ಬಿಟ್ರೆ, I mean, you wouldn't have time to think about the algorithm, the implementation part, right? So annotated data is great. So you may want to make use of existing systems, and transfer learning has proved to be giving you results in state-of-the-art supervised NLP tasks. Andre classification irbodu, extraction, question answering system, these supervised learning tasks ali researchers have proved that transfer learning helps, right? So there are excellent results. So if you try it, you are also expected to be getting benefited by it. Yeah. To give you a case study of how transfer learning has helped a task, this is about named entity recognition. So it was this named entity recognition kind of started as a problem, and people started sharing their accuracies on what was called Cornell data set since 2003. So 2003, that Cornell data set was given. So there were many researchers who proposed different ways of doing it. NER. Excuse me. So deep learning shuru admelu, people were looking at LSTM, convolution neural networks, or probabilistic models like CRF. They gave results, but what gave results, if you could see, beyond 93.5 was in the late 2019, when people used embeddings, transfer learning, right? So embeddings, we will see what are the different types, but the most popular ones these days are BERT, FLAIR embeddings, ELMO embeddings. So these embeddings or these transfer learning algorithms gave excellent results. So this is what I say is the result that is actually in front of us, which says it helps, and transfer learning helps. We actually had a student team here in our college work with Samsung for the same problem of NER. So the baseline model that they built was based on CRF, and they built stacked embeddings. Andre one embedding madodalla, fast text ಮಾಡಿ, FLAIR embeddings ಮಾಡಿ, BERT ಹಾಕಿ, Glove, stacked embeddings ಮಾಡಿ. The student team proved that they had their accuracy levels, which was state of the art. So they got a paper published. I mean, initially we thought we could patent it, but with a lot of open source and people already working on it, we couldn't patent that work, but we did have an excellent publication out of that work because we were working on the current state of the art technology. Moving ahead, as I said, let's quickly look at the types of transfer learning. If it's the same task, you will go for what is called transductive transfer learning. And same task, let's say I'm only talking about summarization, right? Summarization ಮಾಡ್ತಿದ್ರೆ, if I have a summarization being done for sports domain, I could use that model, language model, to do summarization for education domain. So that's an domain adaptation that you would take. Or let's say your summarization for sports in English, you will try doing sports summarization. You haven't changed the domain, you haven't changed the task, but you want to do it with French. That is cross-lingual learning. One model which works for summarization task in English for sports is working, right? You will use that language model for a different language, but the task and the domain being the same. That's one way of looking at transfer learning. Or if you say you're not looking at summarization, but you're looking for question answering system, right? So you will want to look at whether the tasks are being learned simultaneously. Summarization, question answering, do they go hand in hand simultaneously, which is multitask learning? Or would you want to learn the two tasks sequentially? the task of question answering sequentially. So that would be sequential transfer learning, and I would touch upon few things about sequential transfer learning in the slides ahead. So this is the big network of pre-trained language models, as I said. It started off with word-to-vec. Word-to-vec munche, there was encoding, right? There was something called one hot encoding. Data mining ಮಾಡ್ತಿರೋರ್ಗೆಲ್ಲ ಗೊತ್ತದು. There's a lot of overlap between data mining, NLP, machine learning. Right? So it started off with one hot encoding. Amele word-to-vec came into picture, but after that there were a lot of things, which popped up. There was Glove. BERT is the most popular one these days. Elmo no tumba jana use ಮಾಡ್ತಾರೆ. It's an embedding which considers the context. It's not just the word embedding, but it also considers a context. I'll give you an example of that. BERT base and there are so many variations of BERT which have been adopted. So there's video BERT, visual BERT, lot many things which are cross modal, or which has a representation of knowledge graph. No BERT. Yeah. ExcelNet is also very popular, which was an improvisation on BERT. That was also on BERT. GPT actually looked about not just language modeling in one direction, but it was bi-directional language models, and it was a transformer-based architecture. So this is one whole net. I think there's a blog by, I put the link here, you may want to visit it, an excellent blog which tells you the technical details of each of these pre-trained language models. Coming back to sequential transfer learning. There's a pre-training done, and you have embedding. So it could be one of these. Your task would be to adapt it, make fine-tuning, change the hyperparameters to make it work for a task on hand. Right? Okay. Target task. This is source task. This is a target task. Right. So the target task is supervised, and it will span a range of. It could be one of these NLP tasks. You may be looking at document classification, or sentence pair classification, word level labeling, or prediction. It could be any one of these. So to give you a very quick bird view of how these embeddings work, let's say you're using word-to-vec. Text cannot be understood by machine, right? As in, my machine learning algorithm would only look at numbers, vectors, right? So what you would do is convert every word to a vector representation, right? So that is word to vector. So this is the most simplest way of converting this term called cat to a vector, word, or dog to a vector. How does it learn vectors? There is a corpus supervised data, so it learns it, right? So using those vectors, if you have a sentence, right, which says, I love my cat and dog, and if you're looking at part of speech tagging to be done, you understand that will help you identify this cat as a noun. Okay, that's one way. So let's say you're looking at sentiment analysis, and if you say, I love my cat and dog, you understand, or you understand the meaning or the sentiment in it, and you say it's a positive sentiment, right? So that's with word-to-vec. But let's say it's not just word vectors, you're also looking at the document, the sentence. There's a lot of difference between the two sentences when you say you have two cats, or you say it's raining cats and dogs, right? So there's a different meaning. When you say it's raining cats and dogs, it would actually mean it's raining really heavily. So you don't want the two cats in the two sentences to be understood the same way. But how do you know it? You will know it only not just when you see cats, but when you see the entire sentence. You will know, that the two meanings in these two sentences are different. And how do you get it? But not just looking at word vectors, but looking at word vectors in the context. Yeah, so you understand you will have to give a different vector representation to the cats in the first sentence, and the term cats in the second sentence. It cannot be same vector representation. So this is deep learning. So people moved from one layer architecture to the bird that we have today is like 24 layers. You are not asked to learn bird. Yeah, so we understand it's a deep learning transformer based network. If you're very enthusiastic, lot interested in mathematics, statistics, you could go ahead, learn it. Nobody stops you. But you could use it as a black box. You just have to know its functionality and use it as a black box. A quick review of how these embeddings work. So when you see a word to vec and you're guessing, right? So there's a question mark and you say, we have a cat and 3 dogs. So there's a prediction of what could be that question mark. Elmo, as I said, would consider context, right? So it's not just word to word, it considers of what is before. So Elmo, GPT, they're all vectors, embeddings which consider context. Skip thought, this was also a paper in 2015. Not all of them are similar, the same, but there are differences across these embeddings. So BERT uses this technique of masking a word and then predicting. So in the supervised or in the tagged set, you will have the word. So you will have the word, we have a cat and 3 dogs, but it will mask it, it will predict of what that word should be, and it will learn in the process, right? So this paper of 2019 will give you more details on how it works. Actually, there was this paper, I have it open. This paper, which is a thorough survey paper about all pre-trained models. This is from China. This is a paper of last year, same time, March 2020. It's a 25-page document, but I loved it for the reason that it looks at all state-of-the-art pre-trained transfer learning happening in NLP, right? So it compares the different pre-trained tasks, the loss functions in these things. If you could look at this, it says, it kind of clearly tells you which model you should be using, right? So it's a guide. So go through this. I'm sure if you look for a survey paper which says pre-trained models for NLP, this will be the first one that comes up. So a very detailed survey which has gone through around 200 plus papers and has made the summary. So you may want to jump to that when you think you want to adopt transfer learning. Word to vec. Internally, it uses continuous bag of words and skip gram. I'm not going into the technicalities because I know this is not a deep learning course. And language modeling, how would you be benefited by having language models? Pre-built language models is, building language models is a very tough task, and it generalizes over all possible completions, right? So if you take an example, they walk down the street to, you want to find out what, but it cannot be just a named entity, right? So you will have to look into putting a word there so that syntactically also the sentence is correct, semantically also the sentence is correct. So there are a lot of things which come into picture, and language modeling, as I said, is not very easy for that reason. So you're solving a task, your model should learn the syntax, semantics, and how do you bring the knowledge, the world knowledge into that model. Again, the challenge is if you want to build a good language model, you should be given enough data, a huge learning system, and you should have enough compute. People no longer talk about GPUs; they talk about TPUs. Even bigger processing units these days. Given computation power, a very powerful model, and data, you could do a reasonable job. You could build a language model. But what happens with pre-trained model is you have the best of all of these, right? You're not looking at huge data being collected. Nimmalli raw data, you can use it. A model is given, you have to fine tune it, and computationally you can look for resources which work for such models. With respect to how do you make use of it, there are hubs which are central repositories which will help you, or give you access to the common APIs. So TensorFlow Hub or the PyTorch Hub, they have pre-trained models. It's just an API call for you to use those. There are author release checkpoints also, and third-party libraries. You may want to explore these, Alan NLP, AI. They give you easy access. So you just have to import those libraries in your Python code. Just the way I imported NLTK library, you have to use these high-end third-party libraries which could be imported, and it could be used for your task on hand. I think I'm on the last part where I'm not just here to praise pre-trained and language models. There are drawbacks as well. As I said, they are pre-trained, they have enough data compute capability, where a language model can learn a lot from it. But in practice, they're less represented in text, which in the existing data set, which is harder to learn. And when you have large pre-trained models, the way you fine-tune it or optimize it is slightly tough, because fine-tuning would lead to instability or high variance, and especially if your target set on data on hand is very small, fine-tuning becomes really tough, and they're very large. So you need computational power to run those pre-trained models. A couple of pointers to understand, or would say, this is not the solution for everything, but you could try it, right? So that gets me to the end of this topic on transfer learning, and logically the end of this entire session as well. I think it's time for me to take up questions. Yeah, I'll try my best to answer them.
Dear participants, if you have any questions, please post it in the chat box.
Okay, this was a paper which was looking at stacked embeddings.
Madam, we have two questions.
Yes, sir.
One is how LSTM is used.
Okay, bidirectional short term, long short term. Okay. So you will have to go through a deep learning course to use it, but internally all these BERT or the embeddings Globe, the Elmo, they happen to use bidirection LSTM or LSTM and such. So LSTM actually finds its application in multiple NLP tasks. So it could be used. Better way of extracting features. It depends on the task on hand, Anjali ma'am. For example, the features that you're looking for in a summarization task is totally different from the set of features that you will look. So there's a lot of text processing required to learn the features and come up with them. Large amount of data, I wouldn't say you will need big data techniques to handle that large amount of data. But yes, the pre-processing tasks will help you identify the features with respect to the problem on hand. For example, features, let's say I'm talking about movie reviews. The features would be like, movie, is he an actor? What type or what timeline was he working on? Things like that. Yeah, it basically depends on the task. Feature engineering, according to me, is task based. For example, we have this another project of Samsung where we are looking at popularity determination in NLP. For example, if you say play Michael Jackson, you will have to figure out, the application has to figure out that Michael Jackson was a singer and there are multiple albums and it's not Michael Jackson in a different context. See, you would have identified with an NER that play Michael Jackson is a named entity, but it's for you to figure out in the application, of how is he related to movies, or is he related to music, or is he related to politics, right? So to which domain does he belong to? So features, you make a list of features after you identify the domain on which it refers to. Yeah. Sparse data is really tough. Sparse matrix, yes. When you vectorize, when you identify features, and when you have your attributes being filled, you identify most of them go null. Kirti Kumar sir is with this question. We also have such problems in real time. The basic or the fundamental thing that we do is average it out. For values which go null, we average it out, or we take, look at the distribution and, handle those missing data or most of the data which go null. That's the simplest way to do it, but you could find lot many papers, Kirti Kumar sir, which talks about of how to handle sparse matrix. Yes. As a beginner, can I use pre-processing capabilities? No, as I understand, as a beginner, you should initially start up with NLT cases, as in beginner to NLP, beginner to Python, but later move on to PyTorch. That would be my personal suggestion, Muralidhar sir.
I think, madam, there are no questions.
Okay.
We are coming to the end of the session. Okay. Thank you very much for spending your valuable time and share your knowledge with us. The session was more interactive and informative. On behalf of VVC and Department of ISE, we thank you, madam.
Thank you, sir. It was my pleasure to be part of this session, and I wholeheartedly thank all the participants. Yeah, I understand even if it's a smaller number, people who attended have got some insights, some directions into it as beginners in the field of NLP. Yeah, thank you so much.
Thank you, madam. I thank all the participants for attending all the sessions and who made this workshop a grand success. Dear participants, please submit your feedback with the link will be shared in the chat box. Okay, that feedback will be considered for your certificates. Okay, thank you one and all.